All right, so let's try this one. We've got a lot going on here. Y equals -3 cosine of x minus pi minus 2. Holy moly. Okay, let's do our transformations first. Take a moment, see if you can write down what you think, and then we'll check. So to review our transformations, we have a reflection about the horizontal axis, right, because the negative. We have a vertical stretch by a factor of 3 because of that 3 right there. And then we're translating to the right, inside opposite, pi units, and then down, outside same, 2 units. I'm gonna need this space because I'm about to write my graphing steps. Let's get rid of this. All right. So, since so much is going on this graph, instead of just straight up graphing the parent function and trying to then reflect it and change its amplitude and do all that stuff, I'm gonna go ahead and make sure that my step 1 graph, which is gonna be my dashed line graph, is gonna include the reflection and that amplitude change. Okay, so if I graph that as my dashed graph before I translate it, I'm gonna start at, okay, usually cosine starts up, but since I have a reflection, I'm gonna start low at -3. Miss Ryan, where are the tick marks? Oh yeah, always label my graph. So 2 pi to -2 pi. All right, so we're gonna draw in our dashed graph here. We've got our low because we were reflected, 0 high, 0 low, because this is cosine. Okay, so here's gonna be the graph that I translate. I know that once I translate it, I'm gonna finish off from -2 pi to 2 pi. So if it helps right now to just go and finish drawing the pattern in case, we could do that, right? So let's start translating, right? So we're supposed to move to the right pi units, and then we're supposed to move down 2. That means I'm doing 2 things. Remember how that can look like I have points everywhere. So let's make our anchor. Our anchor is gonna be that midline. So our old midline's right here. So if I shift to the right pi units, that doesn't move my midline, and then I shift down 2 units. So my new midline's gonna be right here at y equals -2. All right, so this will be my anchor. So all my points that are on the old midline should end up being somewhere on my new midline. So step 2, we move to the midline. Step 3 is going to be to shift or translate our pattern point. All right, you ready? So this was the original pattern point I graphed, so I'm gonna start moving from right there. And then remember, I'm gonna check them off every time I move them. So I'm supposed to move right pi units. Well, this is pi over 2 units right there. Pi units is worth 2 of my ticks. So I'm gonna take this point, I'm gonna move it 1 tick, that's pi over 2, 2 ticks to the right, okay? Because that would be pi. All right, then I'm supposed to shift down 2. Down 2 units is gonna end up here. Then, now that I've moved this point, remember, I'm gonna check it off. That way I don't lose track of where I'm at. So there's that point, then I've got this point, so right 2, that's 2 ticks, down 2 units, and look at that, I'm ending up on the midline, and it was on the midline before, so that's good. Okay, so then this next one, cross it off. Okay, this one, if I move it right pi units, I'm beyond 2 pi, and we're only trying to graph between -2 pi and 2 pi. So we don't have to worry about graphing this point, so I can kind of check these 2 off. I don't need to graph them anymore. Okay, so now let's go. Okay, this one. So right pi units is 2 ticks, down 2. Look at that, it's ending up on the midline, which is a good sign. Okay, this one. There's a mess of a graph going on up here. I have a lot going on. So what I'm gonna do is I'm just gonna take a moment to connect my dots, okay? Anytime I'm below the midline, I'm gonna make sure I'm making it concave up. Anytime I'm above my midline, I'm gonna make sure I'm going concave down. So I've got 2 pi to -pi, but I'm supposed to finish off to -2 pi. So I'm gonna need to go, okay, well this went low, 0, high. So I'm gonna have to reverse that order and go back to 0, my midline, and then I'd go up and look at, it has to line up to where this guy is. So right about there, because we have that amplitude of 3. So then if I connect, it's looking about right. And we know this keeps going. All right, so let's see if you can fill in the domain, range, min, and max. Okay, domain, all real numbers. Range -5 to 1 inclusive, min of -5s, and then max of 1s.
Here we go, guys. We have a vertical dilation, horizontal dilation, and a translation left, right, and up, down. Oh my gosh, lots to keep track of. So let's start with parent function. Take a moment, write the transformations, and we'll come back together and see if you got it right. All right, so of course we have Vertical compression by a factor of 1/2. Horizontal compression by a factor of 1/2. Wait a second, did you accidentally say horizontal stretch by a factor of 2? I hope not. Remember, it's kind of, we think of it as inside. We have to do something different. So that is the reciprocal 1/2. Translate to the right, pi halves, inside opposite, down 2 units. Okay, so now we're gonna get ready and graph. I'm not doing this in one take. I'm gonna do the partial with the dilations, and then I'm going to translate it after that. So these two, we're going to do our dashed graph, the dilations with the dashed. If there is a reflection, I would do it now as well. There's not, so let's get going. It is, our function is the y equals sine x, and I'm just gonna do the 1/2 sine 2x as my middle kind of practice function. So it's sine. I know that we start here at 0, 0. Oh, wait. We need to label axes. I need to find my period. Oh. Okay, period. Remember, the period is always the original 2 pi times the horizontal dilation, which of course we end up now with our new period of pi. So now that I know the period is pi, I need to go ahead and mark my axes. Remember to do that at all times. So we were instructed to graph from -2 pi to 2 pi. So now that I have my axis label, I'm gonna wait for a second on the vertical because I know there's a vertical compression. But let's go ahead and talk about our period pi. I have to fit one full cycle of sine between 0 and pi, so keep that in mind. You might also want to add a couple of tick marks for my 5 pattern points. How high am I going to go? How low am I going to go? It is vertically compressed by 1/2. So I also know that I just want to go here. Alrighty, sine starts at 0, we go high, back to 0, low, and back to 0. Dash, dash, dash. And then just to make the next step easier, I'm going to go ahead and extend the dashed graph. Okay, let's finish this up. We need to go ahead and move down to, and of course we're going to go right pi halves, but let's get our anchor. Let's get our midline drawn. Down 2 units. So here we have our midline, y equals -2. Is the midline always y equals -2, Miss Ryan?
No, just when we shift down to it is.
Okay, so you're telling me the midline could be up or down and anywhere, not just always at -2. Okay, so now let's do this. I'm going to go ahead and pick up this point, and I need to go right pi halves and then down 2. Well, that one's easy because I know I need to be on the midline. So I did this guy. This high point, that's going to be a little trickier because now, remember, I'm in the middle. So if I didn't make those little ticks along the whole way, I have to keep that in mind. So this guy needs to go over past pi halves right there at 3 pi fourths and then down 2. When I go down 2, I'm at 1/2. So I have to really think about that as well. Down 2 is right about there at -1.5. Also, I could think of it as 1/2 a unit above the midline. 1/2 a unit above the midline. Done with that one. Okay, let's just keep graphing our points. You go ahead. What do you notice about the concavity? Check yours out. Is it looking linear? No go. Concave up, concave down, changing at that midline. How'd you do? Okay, last thing, domain, range, min, max. Domain, that doesn't change unless for some reason in a particular problem we're told it's different. Range, well, let's just talk about min and max because of course that is what determines my range. How low did we go? This green midline is at -2, and if you remember, this is the 1/2 tick mark. Notice I did not label very well on my vertical axis. So if we have the black marks are full units, then this is 1/2 a unit. So this is -2.5. This would have been -3. Another reason why it's important to mark your axes. So the lowest I go is -2.5. And then the highest I go is, well, 1/2 up from -2. So the highest I go is -1.5. Min of -2.5. Max of -1.5. So my range goes from -2.5 inclusive to -1.5. Or interval notation, bracket,
Okay, so we've got y equals cosine of x minus pi over 3. So I've already written my transformations out. I've got my parent function is y equals cosine x. Then I'm translating to the right because inside opposite, pi over 3 units. So we have our parent function as our dashed graph. Now it's time to start shifting. So right pi over 3. Okay, first point. If I move that to the right pi over 3, this is worth pi over 2. Pi over 3 is going to be just a little bit less than that. So if I shift this, boom, there's that first point, cross it off, I've done it. Now this next point, this point right now is at pi over 2. If I shift that, pi over 3 units, I mean, I could make an educated guess, but I really need to figure out where this point's gonna end up. So that's gonna take a little bit of math. So if I'm at pi over 2, and I wanna move to the right, so I'm adding pi over 3 to that, this is gonna be something I have to find a common denominator for. So 2 and 3, well, if I multiply this by 3 over 3, this by 2 over 2, I'm gonna have 3 pi over 6 plus 2 pi over 6. Now I can add and get 5 pi over 6. So this point right here should end up wherever 5 pi over 6 is gonna happen. So it might be a good idea to go retick my whole axis in terms of pi over 6's. That way, all I have to do is sit and count. Reticking with pi over 6. So pi over 6 would happen right about here. So there's my 1 pi over 6. And then 2 pi over 6 is pi over 3. 3 pi over 6, pi over 2. So then it looks like I'm going to have 2 ticks before I get to pi. So if I keep counting up 1, 2, 3, 4 pi over 6, which I know simplifies. 5 pi over 6. Ooh, that's where I'm going to move my point. Okay, 6 pi over 6. So here I'll go ahead and outline that tick. 7, 8, 9, 10, 11, 12 pi over 6. So you can label them all if you need to, but for now, I know that I'm just gonna start counting across ticks. So for this point right here, if I wanna move this to 5 pi over 6, well, I can see it because I labeled it, but wait, pi over 3 is what I'm moving to the right by. So if I look, it looks like pi over 3 is worth 2 ticks. So each of my points needs to move 2 ticks to the right, 2 ticks to the right, 2 ticks to the right, because all of those are worth a pi over 3. So I need this one. So this point, 5 pi over 6, we know it's going to end up there because we did the math, so I can cross that off. But then this point, okay, I know pi over 3 is worth 2 ticks, so 1, 2 ticks, it's going to end up right about there. Cross it off. This one, 1, 2, right there. So this point needs to move pi over 3 to the right as well, so add 2 little extra ticks and get that point on there. Boom, bam, boom, I got it. Okay, so there's my cosine cup shape, but I know I want to draw it all the way to negative 2 pi. So let me get this side of my graph ticked with 6's, so it's easier to figure out where my points are gonna go. Okay, so this little guy here, how many ticks are between each point? It looks like he lines up to here, so 2 ticks, so every 3 ticks is where I want to draw my graph. So 1, 2, 3, and then I'm supposed to be at 0. 1, 2, 3, to continue the pattern, I'd be low. 1, 2, 3, back up to 0. 1, 2, 3, high. 1, 2, 3, 0.